Hello, and welcome back, guys. So, in this particular session, what we will be doing is we will be looking at this particular problem in C, right, where we need to print fidge buzz if it is divisible by both 3 and 5. If only by 3, we print fidge, otherwise, we print buzz, right? So, of course, we need to check for both condition first of all, right? So, to do that, we've got the number, right? Modulo what? 3 equals should be 0. Right, let's just copy the same thing. Copy, paste it there. And we need to check for 5 as well, right? Similarly, we need to check for what? 3 is fizz, right? So the second condition should be if it is divisible by both, it will be fizz buzz. Otherwise, if it is only divisible by 3, or if it is a multiple of 3, that just means the same thing, right? If you are doing a modulo of 3, the remainder will be 0, right? That means it's completely multiplied by, or it can be completely multiplied by 3, right? So there won't be any remainder, or let's just say it's a perfect multiple, right? So first we check for both of them, second we only check for 3, and then there will be another condition where it's not a division of 3, right? So in that situation, what would we do? So 25, right? So 25 would not satisfy this condition, right? So it would be satisfied only by this condition. So it would print buzz. It would not be satisfied by this. Why? Because 25, 3 will give us what? This will give us 4 because 3 7s at 21, right? Or even 3 8s are 24, right? So 1 will be the remainder in this. So that's what it's false. And then this will be true, of course. 25 is perfectly divisible by 5 because there won't be any remainder. So 5 5s are 25. And when you subtract 25, you will get 0 as a remainder, right? So it will be equals to this. But false and true will be what? It will be false, right? Hence this one execute. It will go over here. Check this. It's still false. It will execute, come over here, it will satisfy this particular condition, and you'll just print out. Okay, else what do we need to do? We need to print the value of the number as well, right? So if it does not satisfy any condition, we need to do printf percentage d and then the number itself, right? And that's it. Let's just check our code. What happened? Okay, typo. It's always typo with me. Let's check. Okay, works just fine. See in the 22 because it's not divisible by anything, right? That's why it's working. This is only divisible by 3, so it's fizz. 15 is divisible by both of them. That's why we got fizz buzz. 20 is divisible by 5 only, so we got buzz, right? And then we've got 22 because it's not divisible by both of them. Okay, so number except multiple of 3. Great. Not a big deal. So it's just a loop, and then if it is perfectly divisible by anything, we need to skip the loop, right? Okay, not a big deal, right? So for, of course, we don't need anything. For int I equals to 10, right, and I is less than equals to 10, we need to increment the I as well, right? Next thing that we need to do is if condition, right? We need to check if I is perfectly divisible by 3, modulo is 0. That means what do? We do continue. continue, continue, right? That means we don't print out anything, right? Otherwise, what do we need to do? If it is not 3, if it is not a perfect divisible of 3, we need to print it out, right? So we do I inside there. Let's just check our code. What happened? 10. Why is that? 10, 10. Oh, I started from 10 directly. Nah? I need to do from 1, right? Okay, another situation we need to do. /n, that's a new line. character, right? Okay, we've got it. Let's move on. So count the number of digits. Okay, not a big deal, right? We know that we can count it. Right. So get input value for number. Okay, how do you do that? Scanf, and then percentage d for int, right? And then the number is number. And what else? So we need to count the number of. So this is to print f, percentage g, and then let's count, right? And that's done. We need to loop through. Okay, use a loop to iterate over until number is equals to 0. Okay, we could use while loop over here. While, right, not equals to 0. And what we do, we do number equals to number divide by 10, right? So if we have 123, what will happen? The number will be 120 in the first count, plus equals to 1, right? So it'll be, remember, it's the same problem that we did last time. It will be 120, right? So it'll be something like this. So 120, right? Why is that? Because 10 divided by 123 will be what? 10 12s are, right? 120. The remainder will be 3, right? So the main number is what now? Now the main number is 12, right? So it's 12. So it'll be 10 and then 12. This will be 1. This will be 10, right? And we get a remainder of 2, right? We get a remainder of 2, and the main number now will be 1, right? So it'll be 0 and 0 will be 0, hence it will be 1, right? So the main number is 0 now, right? So it'll come over here, it will provide a count of 1. It'll come over here, it'll provide a count of 1. I mean, count will be 2. It'll come over here, change the number, it will be count will be 3. And then when it goes back over here, it sees like it is equals to 0. That means this condition is not satisfied, right? False, that means it will just move on. Okay, that's how it works. Okay, let's just comment this thing. Let's check our code. Did we miss something? Okay, yes, there should be a and operate and thing, right? We need to provide the memory address of it. See, it's working. Yay, great. Right, factorial. Okay, not a big deal. Loop from int I equals to 1, right? I should be less than number and I plus plus, I guess, right? If the number is divisible by number modulo I equals 0, right? We print the number, otherwise we don't, right? It's easy. What happened? Seems like an internet issue or what? Check code. Okay, great, works just fine, right? Let's move on. Power of a number. Okay, inside the thing, low multiply result. Okay, what do we need to do? Run a loop from 1 to int I equals to 1, right? And it should be I should be less than equals to power I plus plus, I guess, right? So get a program to find the power of a number. Okay, So 2 to the power 8 is 256. Okay, great, not a big deal. Right, in each situation, multiply result with the number and assign it. Okay. Result will be multiplication equals to I guess. I is it either because we need to multiply the same number that many times, right? So it has to be, but with power. 2 8 times, right? So it will just be the number, right? It will just be the number because we have to multiply 2 into 2 into 2 into 2, right? So it will just run for 8 times, but the same number, right? That's why we need to multiply by number. Okay, because that's the important thing. Power we've already used for the loop, right? That's how many times to multiply. And what's the number to be multiplied with is 2, right? Let's just check our code. Yeah, works just fine. Okay, find the greatest multiple of number. Okay, not a big deal. So for loop from 100 to thing, okay, and I equals to 100, right? Unless I is greater than equals to 1, let's do a plus plus. Check if I is divisible by a number, right? So if I modulo number equals 0, right? So it's just getting the multiple kind of thing, right, of the number. Okay, we need to print f and then we need to exit out of the loop, right? So we do percentage %d and then it should be I, right? And then we need to break out of the loop as well, right? Let's check our code. What happened? 9 expected output is that. Okay, it should have been 11 over here because it's perfectly thing, right? Why is it 108? Not plus plus, nah, minus minus. Right, we are incrementing it. Yeah, works just fine, right? So internal angles over angle, right? We've got 3 scanf. Sum is basically sum of all those things. Check if the sum is equal to thing. Print either true or false. Okay, it has to be true or false in words. If sum equals 180, right? Do something. Print f, print f. It's a string literal, right? true, true. Let's copy it. Else, open the bracket, paste it over there, and it should be false, I guess. Right, let's run the code. Yeah, it works. Okay, sum of all digits of a number. Okay, of course we will need while loop, right? We know how to do that. Basically it's going to be number modulo 10 will give us the remainder, right? And in the sum will be a digit. We get the digit plus it will be sum plus digit, right? We could have written it plus equals to digit directly, but just to make you guys understand, we're just doing it like this. Okay, next thing is we need to do printf modulo d sum, right? That's it. Woohoo, works just fine, right? Remember how it works? When we've got this number, when we do the modulo first, we get what? 2 at the beginning, and then we change the number to 4380, right? In the next loop, what happens? Our number is 4380, right? All right. In that situation, what happens? We get some kind of remainder from it, hopefully, right? And we just add it to the sum, and then we change the number to 4380 divide by thing. So it will be 438 after that, right? So we'll just keep on adding up. Okay. Okay, check Harsat number, right? So create a number a program to check if the number is Harsat number. So it's an integer which is divisible by the sum of its digits. Right, so we need to check if the number is perfectly divisible by 3, right? So of course we will need to find the remainder, print out that, right? So sum equals sum modulo number equals 0. That's the logic, right? So if it is, if the sum of the digits, right, 2 plus 1 is 3, 3 divided by the number itself is what? I mean, it should be number divided by sum, right? Yeah, number modulo sum, right, equals to 0. That means it works just fine, right? So how to find that? Of course, we know that number remainder of 10 will be, what will happen? So in the first, the digits will be 1, right? So how does that work out? Okay, let me just open up a comment line over here, right? How does that work out? 10, 21, yeah, right? And then it will be 10 puza, right? So it must be 20, right? So then what happens is basically we got a remainder of 1 over here. What's our main number now? It will be 2, right? We are changing it, we are assigning the number over here, right? So it will be 2. What will be the thing? It will be 0, right? So then we get a 0 over here, we get a remainder of 2, right? And then the loop exits basically because it's 0, the main number is 0, so it's not going to satisfy this particular condition. It's equals to 0, right? So we get the digit out of it, right? So we get the, we know the remainder is this 1, and the next remainder is 2, right? So when we add 2 to 1 plus 2, it will be 3, right? So we are going to do the same thing in every other loop, right? So sum plus digits, and then we assign it. This is the short form for it, right? So this is equivalent to doing something like sum plus digit, right? Then we basically in the second, what happens when we come in, the number will be 21. Modulo 10 will give us what? A remainder of 1, right? And in the sum is 0 at the beginning, so 0 plus 1 will give us 1. We add it to the sum. Next thing, what happens? Number, it's still 20. 20 divided by 21, divide by 20, 10 will give us what? It'll give us 20 point something something. I mean, it'll give us 2 point something, 2 point something something. So it's an int, right? Number is an int. So that means it will just chop off everything after it. So it'll just give us 2 only, right? So it'll just give us 2 only. So number is 2. It goes back, it checks over here. It's not equals to 0. Yes, this condition is satisfied because number is 2. So it's not equals to 0. That means it's satisfied. It goes inside. The number is 2. 2 modulo 10 will be what? 2 remainder 10 will be what? 2 remainder 10 will be 2, right? So it'll give us 2 over here. And remember, how much is the sum? It's 1 from the previous iteration, from the previous loop, right? So 1 plus 2 will be 3. So we've got the sum, that is 3, right? And next thing, what happens? So we've got the number, this number is 2, right? So 2 divided by 10 will give us what? It will give us 0, right? Because it will be 0 point something, right? It will be 0 point blah blah blah, something like that. So we'll chop off that because it's an int value, right? So it will get rid of the floating point number, and the number is 0. hence when it goes over here, it checks the number is 0 and it's not equals to 0. That's false, right? Because it's equals to 0, right? It's equals to 0. The number is already 0, right? So that condition is thing, so it basically gets out of the loop, right? And it comes over here. We know the sum is 3. The number is, what's the number? It should not be NUM, okay? It should be NUMBER because the number has already changed to 0, right? So that's not correct, right? It should have been number, okay? So that's the original number. We need to keep it as it is. We should not use the same variable. We are using or creating another num variable just to preserve the original number, okay? Because at the end we need to check for this condition now. That's why. Okay, hopefully you've understood it, right? So that's how we solve it. Okay, so abundant number. So create a program to check if a number is abundant number. Is a number in which sum of all its divisor is greater than the number itself. I'm not so sure. Okay, so it's like what we've been given a number. All right, 12, right? So it's divided by all this number and the sum of it is greater than 12. Okay, not a big deal. Right, so we need to check sum is greater than the number. It's the similar concept, right? It's somewhat similar concept, right? We need to check. So if number is perfectly divided by I, right? So if there is no remainder, that means it's a perfect divisor, right? And then we simply do sum equals to plus equals to I, right? So if it is 12, what happens in the first iteration? It will be 1, right? So of course it 12 by 1 will give us thing, so it will be 1 added. Next loop 2, right? So 12 by thing, 12 by 2 will give us, it's a perfect divisible, it will be added, right? So it will be 3 over here, then it will go like this, right? So that's how it basically works. Okay, so that's also done. Next thing, we need to create a calculator. Okay, first and second character. All right, we need to get the input value of first and second. Okay, we are using switch, huh? We are using the operator. We are asking for the user to do it. Right, so we need to use something like this, right? Case is, so it's a character, I guess. Yep, it's a character, right? So we can compare it. So that's how it works, right? So this is right, like similar to writing else if kind of statements, okay? So switch is this OP and it should match with what? If it is plus, what do we need to do? I just could have just uncommented this and that's it, right? We could have just done the same thing. Yeah, right. So similarly, we can do something similar like this, like this, like this. Get rid of all this thing, right? We don't need this, we don't need this, we don't need this, right? We just need to write the functionality inside it, right? Similar thing over here, print, right? We simply need to change the operator only, because when the user is saying it's they want to do minus, of course we don't want it to do plus, right? So whatever the operator is in the case, we simply do that, right? So it's like writing if, if op equals to this in string, right? So if plus, like that, right? So it's similar to, like this. So if op equals to plus, right? So what do? We do this. It's same basically. Okay, it's basically the same thing. It's just a better way to organize it. Okay, when you've got multiple else if kind of situation, it's better to use this. It looks cleaner as well, right? So if it does not match, of course we say it's error, right? And we check the code. Okay, what happened over here? And divide, right? Okay, okay, we did not do divide. Okay, now it should work, right? Okay, works just fine. Let's submit it. Let's move on to functions now. All right, so we need to see if the number is Armstrong or not. So we need to create a function which checks that, and we need to call the function as well, right? So inside the check Armstrong, create a function and prints out. I'm just doing that. I'm just doing that, and create a variable with the original value. Now we need to call check Armstrong for each value from X. Okay. Right, we need to get to input and then run a loop from X to Y. Okay, call the check Armstrong function with X in each iteration. Okay, we need to pass X over here. Right, inside over here we need to take a variable, right? Function parameter should be original number. Okay, not a big deal. Original number equals to 0. Right, sum equals to 0. Right, and remainder equals to 0, I guess. Right, of course we need to define the data type. Int over here, maybe number equals to 0 over here, huh? We don't want to change it. Run a while loop where condition is original number is not equals to thing. Okay, let's do that. So while, right, while original number, let's just copy the whole thing. Right, inside the loop, what do we need to write? Find the last digit using this. Okay, not a big deal. Int digit equals to original number modulo modulo 10, right? That will give us the last digit, and then add the cube to the last in the sum variable. Okay, so sum equals to, it will basically be digit into thing. Okay, so digit plus, I mean not plus, into will be something like this, and then we need to change the original number as well, right? Original number equals to original number divided by 10, right? Okay, outside the loop we need to if the sum is equal to number, we need to print it. Okay, so if sum okay, so there is a mistake over here already. We need to preserve the original number. So if sum equals number, All right, okay. So that's basically what it's saying us. So int this, and then it's going to be number. Okay, so this should be number. Right, so we are just using that since we need it over here, right? We don't want it to be changing. Right, so we need to do printf, right? Printf and then percentage %d, and then we simply print the number. That's it. Assume that the input value is thing, right? So if it is 100 and 500, right, what happens? So 100 is less than thing, okay, and it checks for 100, right? So in 100 it basically will give us a sum of 1, I guess. Basically this condition won't be satisfied, right? Because sum is 1 and the number will be 100, so it won't be satisfied, right? So there are only few numbers that get satisfied. Okay, great, not a big deal. Let's check our code. Hopefully there is no mistake. Okay, what happened? What happened? It is 153. Right, let's check. Our output is still thing. Why is that? Why did that happen? Right, why is this thing not running? Why is this condition not being satisfied? That's my only question. Let's see. I'm calling the function correctly, I guess. Okay, 153 is being called. Right. Okay, that's fine. But what's the issue? Is it equals to original number, right? So that will be what? So if it is 153, right? 153 comes over here. When you get it, we get 3 in the thing, right? So 3 into 3 into 3, 27, right? So 3 cube will be there. Yeah, 27 will be there. And then after that, it basically changes it to 150. Right. 152 is there. What we can do is, of course, we can always use a debug statement, right? Let's just check the sum. So let's not run this thing for now. Right, so we just want to check for this particular condition only. Right, so let's just uncomment. Let's uncomment this. Comment out this. Right, let's just run this thing. Output is 1, huh? Why is that? Why is it not? I know why. Because we need to plus na sum plus the digits na, that's why. Because otherwise it's just going to do the last digit of it only, because last digit will be 1. Right, that's why. Oh man, silly mistake. Right, we pass x. With the heel. The heel happened. Why not do 153 and then let's uncomment it. Let's check. Okay, 153. Okay, we don't need this printf, right? Let's check code. Hopefully we get 153. Yeah, okay, great. So let's uncomment this thing. Let's uncomment. I should have passed x. Check code. Okay, of course we need to do slash n over here because we need to print out a new line, right? Yay, works. All right, let's submit it. So prime number between intervals, right? Okay, we need to check if it is prime or not. Right. Okay, and end of it, what do we need to do? Okay, we need to basically just print it. So it will be a void function, right? It won't return anything. Prime number, and it should be like this, right? We need to create a flag, right? So we will need to take a int of number, right? And it should be what it should be. Flag equals to 0. Of course, it will be int, and we need to run a for loop for I int I equals to 2. I is less than number with I plus plus, right? From the function parameters, check if I is divisible by thing. So that's easy, right? If check if number is divisible by I, divide by I mean it should be modulo I equals 0, right? Then what do we do? Printf, no printf, flag only, flag equals to 1, right? And outside over here we need to check we know 1 is always true, right? So we can simply do if flag if flag equals 0, right? So we need to find all the prime numbers, right? So it is not divisible. So if it is 0, right, that's why we need to find which is not divisible by any number, right? So we are finding the prime. That's why we are doing flag equals 0, right? And print the number. Okay, comma number only, right? And of course inside over here, from x to y, for each iteration we need to call this thing, right? Run the loop from x to y, right? So let's check for every I, right? So we need to check how many numbers between them 21 and 50 are prime number, right? That's what it's basically doing. So I will be 21 in the beginning, right? And then it'll go on changing, of course. So let's check the code. Of course we need to do slash n, but I think it works, huh? Great, works just fine, right? So self-dividing number, number is a self-dividing number, is divisible by every digit it contains. For example, 128, 1, 2, and 8. Okay, so we need to find all the digits, first of all. Okay, we need to do a function call over here first of all. Right, of course we might need to pass in the number, right? Otherwise the function is not going to know it. And result, what do we give out in result? Return 1, otherwise 0, right? So of course we can just use this, right? So inside the function, that's where the main loop thing happens, right? So we need to check uh, the number. So we've saved the original number, we've created a temporary num variable. All right, so we need to get the digits. All right, we know that digit equals to num modulo 10, right? So we need to check for every digits, right? So we need to check if it is divisible by thing. All right, so let's just do that. So if, right, if any digit is divisible by the number, does not divide, return 0, right? So if uh, 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 number, right, modulo, it has to be thing, it has to be the original number, not the num variable, always, because the num variable keeps on changing for the loop purpose, but our 128 is constant, right? We need to check for that particular number only. Modulo, what's the digit? And digit will be 8 in the beginning, right? It's not equals to 0. That means we simply do a return 0, and then we simply do right. One thing that we need to be worried about over here is the loop will work just fine. The only logic that there is basically we don't want to return it right over here, right? We want to check everything completes and then only return, right? So that's being done over here. Okay, great. So this solves it, right? So we want something outside the loop to keep track of it, right? So return 0. So this should handle it, right? So if it is not divisible, it will, if the first number does not do it, it will return 0. If the first number does it but second does not, it will return 0 similarly, right? So if everything works just fine, of course it will come over here, right? Otherwise it would have basically returned from here itself, right? So that's why when we run it, it should work just fine in my opinion, unless there is a typo. Okay, works. Okay, it's already 43 minutes. Okay, so let's just solve this thing first. So what is this? Of course, we simply do the similar kind of thing, right? So find some, pass in the number, check if the result is equals to this perfect number, not a perfect number. Okay, right, else something like that, and that's the structure, right, that I want to write down first. Right, it's going to be a perfect number. All right, first of all, I simply visualize, like what's the output or what kind of thing that they want to do. Makes the job a little bit easier. All right, we need to check if result equals the number, right? Okay, that's done. Now let's go into our main result, right? Of course, there has to be a sum kind of thing, right? Because it's not 1 or 0, because this number could be a bigger number than 1 or 0, right? So 6, right? Of course, they want something like this, basically. So we need just to run the loop, basically. Right, we need something like plus equals to 0. I mean, plus equals to I. That's it. That's the only logic that they want. I'm pretty sure I equals to 1, right? And it should be I is less than 6, right? Of course, we want to loop until only 5, right? Don't want the 6, because of course 6 is divisible by 6. So I plus plus, and there is a mistake over here that I need to fix. I will need a if condition, because I need to check for division as well. So if number is perfectly divisible by I, then we need to do something different. And it should be something like this, right? And we return the sum already over here, so no need to do anything. Check code. Hi, just a typo. Another ignore, another ignore. Okay. Why did that happen? Of course, I forgot something over here. Equals 0, na? That's why. Because this was returning 0 always. That's why. This condition never executed, right? What is this? Perfect number 28, 28, 28, 28. Mm-hmm. My only concern is, why is it returning 7 over here? 28. All right. So we need to do print s somewhere here. So when it is 28, right? Why am I doing 6 over here, man? Should have been number now. That's why. Maybe it was just my keyboard acting up, my typo. Huh? Yeah, that's it. All right. So yeah, that's pretty much it for today, I guess. Right. Hopefully, maybe I'll be back and solve other problem. But yeah. So we've solved a lot of problem. Right. So it's already 48 minutes. So I'll continue in the next part video. Thank you for sticking around, and take care. Bye bye.